Hello, sir. Tremendous honor to have you on the podcast. Could you introduce yourself, please?
Yes, hi, thank you. I am Dr. Derick Lindquist, and I am the Dean of the Jindal School of Psychology and Counseling at OP Jindal Global University. Just a quick introduction, I'm from the US originally. I grew up in the Western US. I got a bachelor's in psychology. I followed that with a specialization in behavioral neuroscience. So I did this at Yale University, where I studied and ultimately received my Ph.D. in 2004. Over the next 15 years, I did what's called behavioral neuroscience research. This is essentially the biological side of psychology. But during that time, I investigated the neurobiology of learning and memory. So essentially, how do we encode and store memories in our head? In 2019, I moved to India, joined OP Jindal, and then last year they had me start up this new school of psychology. And it's been a great experience so far.
Could you tell us a bit about the school?
Sure. Glad you asked. Thank you. So we just welcomed our first batch last year. We're warming up to bring in our second batch. And this is the 10th school at OP Jindal. So OP Jindal is a relatively new university. It's only been around since 2009, but has garnered quite a few awards and accolades. So for instance, they're designated an institution of eminence by the Ministry of Education, one of just 10 universities in India. And the QS World Rankings, a very prestigious rankings organization, has listed OP Jindal as the #1 private university in India for the last 3 years running. So this new school of psychology, we've got about 350 students so far. And it's been a great opportunity. So they get a really broad exposure to psychology during their first 2 years. During the third year, we give them the ability to kind of customize their coursework based on interest and professional goals. And we really put a big emphasis on experiential learning. So all of our students are involved in doing practicums and internships and other things. So we're a new school, but I feel really good. I think we put together a pretty good program so far.
Right. Sounds fantastic. So the topic we are going to talk on is learning and memory. So can you start by the definition of learning and memory?
Sure. Learning and memory is one of those terms that I think everybody knows. But when you actually try to operationalize it, that is, you try to really define it, it becomes a little bit more cumbersome. But I think, on a sort of a basic level, learning is taking a new information that can be used to predict future circumstances or scenarios. And memory is really laying down that new information in your head and making it permanent. So one of the interesting things about learning and memory is, up until the 1950s, it was really thought to be kind of this unitary phenomenon, right? There's learning and memory. Beginning in the 50s, we have this really famous case study in psychology based on a guy named H.M. He suffered from epilepsy. He went in and he had surgery. Basically, they destroyed a part of his brain, right down to the bottom here. And they took out a portion of his brain called the hippocampus that some of the listeners may have heard of. And while it did improve the seizures, that is, it reduced the frequency, he suffered from amnesia as a result. He was unable to form or store new personal autobiographical memories from that point forward. And so this kind of led to a renaissance with the recognition, there's different types of learning and memory, and those different forms of learning and memory can be stored in different brain regions. So today, at sort of a gross level, we recognize what we call declarative versus non-declarative, or explicit versus implicit. The explicit would be, right, your personal memories, right? So what did I have for breakfast this morning? Or where did I go on vacation earlier this summer, right? Personal autobiographical memories. But it also includes our knowledge of the world. We call this semantic memory, right? So do you know what language they speak in Portugal? Or it was not a very good question. Yes, I actually meant to say, do you know what language they speak in Brazil? But yeah, okay, I flubbed that up. But the point being, I'll still make it is, right, that's knowledge of the world. And what's kind of cool is we have something called meta-memory or metacognition, where as soon as I ask the question, right, you know whether you know the answer or not. That is, you know what you know and you know what you don't know. So explicit declarative memory is autobiographical in nature and or knowledge about the world. On the non-declarative side, and we call it non-declarative because you don't need conscious awareness to learn.
Right.
These memories are sort of stored automatically. So this would include what we call non-associative memory, kind of the most simple form. One example of this would be habituation, right? So you move into a new apartment and you've got traffic and barking dogs, and it keeps you up for the first few nights. But over the next week or two, you begin to habituate. You respond less and less to these stimuli until eventually you don't even really notice it at all.
Right.
So habituation is a very simple form of learning that we see. Next, we have priming, as well as procedural memory. So procedural memory would be sort of muscle memory, right? Our ability to ride a motorcycle or a bicycle, your ability to walk, your ability to hold a coffee cup, right? All of this are forms of what we call procedural memory. And then finally, the area that I've been most interested in myself is associative learning. So this includes both classical conditioning, like Pavlov and his dogs, as well as instrumental conditioning. Right. So this would involve a stimulus, a response, and a consequence. Right. So if you're a kid in middle school, and your mom and dad say, "Hey, we'll give you 100 rupees for every A that you get," that's positive reinforcement, right? Stimulus leads to a response, which the outcome, if it's positive, that reinforces or strengthens that response. The subject's more likely to do it again. If it's negative, punishment, right? That is going to weaken or lessen the probability of that response being committed again. So the point being is that today we really recognize that there's this distributed system when it comes to learning and memory. And not only can we see different types of learning and memory, for many of these, the underlying neural architecture, the underlying neural systems that are involved are also distinct one from another.
Okay. So does hippocampus take place for all of these types of memory?
Yeah, great question. So the hippocampus is really critical for these declarative memories. So specifically, again, your autobiographical and those semantic memories. But there's actually a third memory that I can introduce here called working memory.
Right.
So working memory is sort of whatever is in the content of your mind right now. So what's kind of amazing about it is it offers a lot of flexibility. And to go off on a slight tangent, the front part of your brain is called the prefrontal cortex, and it's associated with these higher order cognitive abilities. We call them executive functions. So one of these is working memory, the ability to hold information in mind. But it's also the ability to pay attention or focus. It's the ability to plan, right? To plan out your day. Here's what I need to accomplish today. It's the ability to regulate and monitor both your emotions and your behavior. So all of this sort of falls under the domain of our prefrontal cortex and these executive functions. But with respect to memory, we have both short-term and long-term memories, and we can have the discussion of how that's encoded and how that long-term memory is stored. But ultimately, you can take that long-term memory and you can place it into your working memory, right? So if I was to ask the listeners right now, right, think about your high school graduation. Or if you're a little younger, think about your last birthday, right? So by placing that memory in your working memory, you now can come at it from different perspectives or different angles, right? So if you're thinking about your high school graduation, I can say, well, what was the weather like, right? Who were you sitting next to, right? Who was the speaker, right? So again, you can kind of probe or sort of come at this memory from many different perspectives. And essentially, that's the working memory. It's this ability to manipulate that information that's within your mind at any given moment.
Right.
So most of the time when we're doing that, those are declarative memories. Because again, it's your autobiographical, your personal memories, or some sort of fact or piece of knowledge of the world, right? That's what you're thinking about in your working memory. The classical conditioning, the instrumental conditioning, the habituation, again, that's sort of occurring at a non-conscious level. So there's really not much there to kind of pull into your working memory and think about. So at the end of the day, then, this explicit memory, again, it's these two different categories explicit. So again, you have both the personal, the autobiographical, or the knowledge and the semantic memory. And ultimately, you can place either one of those in those working memories where you can manipulate it, update it if need be, so on and so forth. So for instance, by updating, I mean, let's imagine I asked you again, I got the question right the first time. I asked you what language is spoken in Brazil, and you said Spanish. Right? I go, no, it's actually Portuguese. Well, again, you can update that knowledge in your head. And so all of that is continuing all the time.
Okay. So what steps can we take for the proper encoding of information in our memory?
Right. So encoding is really learning something new, right? So encoding is occurring both with our initial learning and it's encoding with memory. So just to sort of clarify something here, because sometimes people conflate these. Learning is habituation. Learning is classical conditioning. Learning is instrumental conditioning, right? I'm taking in new information and I'm actually learning something new about the world. That is encoding. But even with these declarative memories I just talked about, you don't learn about your personal or autobiographical memories, right? It's just like a continuous recording. You wake up in the morning, you open your eyes, and you start laying down that information. So it's still being encoded, but it's not necessarily being learned. It's just being encoded as a result of being conscious and aware and living your life. So when we think about the encoding of new information, whether that is in your hippocampus or if it is classical conditioning, it may be in a structure called the amygdala. If it is instrumental conditioning, a structure called the basal ganglia becomes involved. So there's different structures that are engaged. But at the end of the day, the ability to encode new information or to encode a new memory really relies on altering the connectivity between different neurons within these various brain substrates. Okay. Now, 10 years ago, when I was really kind of sort of full-blown in terms of the research, our best explanation was that this involved changes in what we call synaptic weight. Now, I know we have limited time, so I won't go into this in great detail, but sort of neurobiology 101, right? We have a neuron. Neurons have a couple of different components. They have a dendrite, which receives incoming information. They have a cell body, and they have an axon. That axon can generate an action potential, which is just sort of an electrical blip that travels down the axon. It invades the terminal, and that electrical signal, that action potential, is converted into a chemical signal. It leads to the release of neurotransmitter. Right? And again, I assume a lot of your listeners are familiar with dopamine or serotonin or other neurotransmitters. Okay? So that neurotransmitter is released and it binds to the receptors on a new or different neuron, specifically onto the dendrites, the dendritic spines of a new neuron. So action potentials are the primary means for neurons to communicate, and the neurotransmitter is being released at a synapse. Okay? So a synapse is simply this axon terminal on one end where you have neurotransmitter being released. On the other side is another neuron with these receptors or that neurotransmitter combined. And the synapse is just simply the two of those two junctions. Okay. What we know is there's something called synaptic plasticity. That is, we can vary or alter the weight of that synapse. Okay? So imagine I have an action potential and I have two dopamine neurotransmitter molecules released. That's going to have a relatively small effect on the postsynaptic receptors. But through different mechanisms that, again, we don't need to go into, I can change that up and down. I can reduce it down to one molecule of dopamine being released, or I can increase it. Maybe there's 10 molecules of dopamine being released. So the idea is that that synapse is plastic, is dynamic. That synapse can be modified. So to come back to where we were, the idea then is that a memory, you have some number of neurons that are all connected together. And as you encode a memory, it's leading to alterations in that synaptic strength. We call it synaptic plasticity. Okay? So synaptic plasticity, changes of the synapse itself, is ultimately what's going to lead to the encoding of this memory.
It's fascinating.
Now, again, we can strengthen or we could weaken that synapse. For a memory to occur, we want to strengthen it. We want to ensure that when one neuron is activated and it releases neurotransmitter, which binds to that second neuron, by strengthening that synapse, by making more transmitter available, we're more likely to activate that second neuron. And that second neuron then can activate or drive a third neuron and a fourth neuron and a fifth neuron and a sixth, seventh, eighth, ninth, and 10th. And ultimately, if you put all of those 10 neurons together and they're all firing together in synchrony, that's a memory. That's a memory of your high school graduation, right?
So theoretically, if we come up with a machine that can fire all those particular neurons together, can we remember that event?
You can, absolutely, and that's actually been done. Okay. So this is called a memory engram, and this has been done in animals. So there is a technique where we can go in and we can artificially activate different neurons and their synapses within animals. And by doing this, we can essentially create a memory in an animal, and we can encode or sort of record how that memory is laid out with respect to the various different neurons. And we can recapitulate that into another animal. And the second animal behaves in a, I won't say quite identical, but very, very similar manner to the first animal, suggesting that we have introduced a new memory. Now, I want to be clear that these are very simple memories. This is usually, again, classical conditioning. So imagine I put that first animal into a context, unique because it has a particular floor and some pictures on the wall and a unique scent. Right? It's unique in the sense that the animal can recognize it. So I put the animal inside, we'll say it's a rat, and I shock its feet. Right? Doesn't injure the animal, but it's not pleasant. The animal doesn't like it. So if I was to put that same rat back in that context later, well, it's going to show me that it remembers by demonstrating a freezing response. Meaning I put it in that chamber, it looks around, and it goes, oh, I'm back in this chamber again, and it freezes. Okay, so I can record the amount of freezing in that animal, and I can use that as a stand-in for the memory. The more it freezes, the stronger that memory is. Okay. So as that association takes place between the context in which the shock is presented and the shock itself, that leads to this memory engram. So again, we can record that memory engram, put it into another rat, a rat that's never been into this context or this chamber before. But I stick it in there the very first time, it looks around and it goes, uh-oh, and it starts freezing. So this idea that these memory engrams are responsible for how our memory is encoded is pretty well validated. Now, one of the interesting things is that we're beginning to discover that it's not just synaptic plasticity, it's not just the changes in the weight of these synapses and how well or how efficiently they work. There's other features at play in terms of the electrical properties of the entire neuron and other things. But by the end of the day, it really comes down to a group or a set of neurons that are interconnected with one another and their ability to be activated. And that memory engram, that interconnected set of neurons, is, again, what we experience as a memory. And one of the interesting things about that is, I think you and probably everyone has experienced it. You know, sometimes we have some brief sensory experience, right? We're walking down the road and we see something, or maybe we smell something, or we hear something, and it automatically just sort of recapitulates some memory that pops in your head, right? And you're thinking about some experience from the past. It's just automatic. It's just there without conscious recall. Well, if you think about this memory engram, right, these interconnected neurons, if I activate even a single portion of it, we'll think of it as just one neuron, right? I have some stimulus that comes in and it activates that one neuron. But because all of the neurons within this engram are interconnected, once I activate the first neuron, it activates the second and the third and the fourth, and before you know it, you've reactivated that entire memory engram. So that's why even a single stimulus that is only a subcomponent of the original memory, it can recapitulate the entire thing.
Okay. I would like to ask you, if someone wants to enroll in the college, what is the procedure?
Sure. They obviously just go onto our website, jgu.edu.in/JSPC, and we got information in there about the school and how the students can get the admissions information. And there's admission officers on there that they can reach out and contact as well.
Okay. So, in what ways are brain altered when learning takes place?
Well, so again, ultimately, it's the idea that we're modifying the neurons within the brain and the synapses by which they communicate. So that's that memory engram. But what's also cool is, so initially you encode, and then we have something called consolidation, right? That's making the memory more permanent, making it more durable. Okay. So that's why, if you think about what you had for breakfast this morning, I'm sure you can remember that. That's in your short-term memory. The memory, short-term memory, is usually only there for a few hours, maybe a day or so, maybe even a week, but it's not permanent. So you can remember what you had for breakfast today, probably tomorrow, maybe even the day before, but last week or 2 weeks ago, you probably don't remember what you had for breakfast, right? It's just not important. So you encode that information, but it's not reliably consolidated. It kind of fades over time and you forget that information. So the stuff that we can remember is information or new short-term memories that have been consolidated into long-term memory. They've been made more permanent. Okay? Now, even there, long-term memory, you can have a lot of variability, right? It may be a few months, it may be a few years, it may be decades, it may be an entire lifetime. So it really comes down to how strongly is that memory consolidated. So there's two ways, more than that, but I'll give you two, that we can increase the consolidation of our memories. One is simple repetition, right? I think every student knows that if you're studying for a test, right, you repeat that information over and over again in your head. And that process of rehearsal helps store and better consolidate that information, right? So a very simple technique that I think everybody's probably familiar with. The other way we can increase or enhance consolidation is through emotional arousal. Okay? Because if you are highly emotionally aroused at the moment you are experiencing something, the odds are that's something important. It may be something you actually want to remember later. So we know that emotional arousal, which is largely this activation of our fight or flight response. Yeah, maybe you have heard of that, or other listeners out there have heard of that, right? That's that almost instantaneous response that we have when we're, say you're startled, you hear a loud noise, right? Your heart rate's thudding and you're breathing fast and your pupils are dilated, right? You're sweating. That's the fight or flight response. That's emotional arousal, okay? So if I have some mundane experience, right? I'm walking down the street to my classroom or to my office, or again, I'm sitting and eating lunch. Those memories are likely to fade over time. Again, they're in your short-term memory. They may not make it into your long-term memory very easily. But if you have a fight with your spouse or a significant other, if you're crossing the road and you almost get hit, right? If you have emotional responding underlying that experience, that memory is much more likely to be encoded and consolidated at a high level, making it available for later recall, later retrieval, okay? And in fact, the fight or flight response, that kind of emotional arousal, leads to the release of two compounds. One is adrenaline, which I think everybody knows what a surge of adrenaline does to you, right? It's like that. But you also have another one called cortisol. And in the brain, cortisol leads to better consolidation of the memory. Now, what do I mean by better consolidation? Well, again, we just talked about the idea of a memory engram, right? All these neurons connected at their synapses, one with another. So by better consolidation, I mean the synaptic change, that synaptic plasticity, is even bigger. There's a greater increase in the connectivity. So if one neuron fires, the odds of the second neuron and the third neuron fire is dramatically enhanced. Okay,
right.
That's what we mean. Now, there's another way we can think about this, because ultimately that change in the strength of the synapse is what we call a functional change, right? We've changed the function of the synapse, we've made it stronger. But if I really want that memory to last for years or maybe even decades. The alternative is I need to make a structural change in the brain. I need to actually modify the biology of my brain. So we have one neuron here and we have one neuron here, and they're connected by, now this is never true, but we're just, for argument's sake, we'll say there's one synapse connecting them, right?
Yeah.
So initially, I'm increasing the strength of that synapse. So this first neuron fires, it's more likely to fire the second neuron. That's what I mean by a functional change. A structural change is, okay, there's one synapse, let's make more. Let's add in a second and a third and a fourth, maybe even a fifth. So now every time this first neuron fires an action potential, there's 5 synapses connecting it to the second neuron. You can be pretty sure that second neuron is going to fire as well.
Right.
And because it's a structural change, it's an actual change in the biology, that is much more durable. That can last for years or decades or even an entire lifetime. So this is how we ensure that those memories are available to us, again, long time later. And when we think about emotion, probably the most robust version of this is what we call a photographic memory or a light bulb memory. And this is something that's so traumatic, something that's so emotionally arousing that we feel like that experience is almost tattooed on our brain. Right? I heard a radio speaker explain it this way one time. So for me, growing up in the U.S., the sort of the classical example would be 9/11. 20 some odd years later, I still remember what I was and what I was doing and who I interacted with, right? That memory's just burned into my brain. Here in India, maybe it's some Mumbai attacks or other things. But we call it a light bulb memory because, again, it's almost like that memory is just, it's so ever present. It's just burned into our consciousness. Now, interestingly, I will say that there's been a lot of work that's looked at this. And with a light bulb memory, so my memory of 9/11, I feel very confident that I remember almost everything from that day. But psychologists have actually researched this, and what they find is that with a light bulb memory, the actual confidence in the memory is dramatically increased, but the reliability of the memory is no better than any other long-term memory. I mean, there's certain errors and disruptions, and I don't remember it perfectly. It's not a perfect representation of what happened. But my confidence is so high. I just feel like it must be true. I remember everything. That's what makes it.
Yeah, could it be because of the social pressure that everybody remembers what happened? That's why we have to remember.
I think that's certainly part of it, particularly early on. Now, the first decade after 9/11, people talked about it so much and it's on the news. And so again, you're just exposed to it so much that each time you do, you sort of re-strengthen or enhance the consolidation of that memory. Now 22 years later, do people still talk about 9/11? Sure, but it's not as ever present as it once was. But do I still have the confidence that I remember it? I do. I mean, truly, if I think about it, it feels like I can remember virtually every moment of that day. But in fact, again, we know that that's not true. I'm overconfident. In fact, I don't remember that long-term memory. I don't remember that memory any better than any other long-term memory in my head. Now, that's not to say that it's, not correct, but it means it's only partially correct, right? Our memory is not like a photograph or a video, right? It's not a perfect representation. It's sort of filtered through our senses. It's filtered through what we're paying attention to during that experience. And ultimately, there's corruptions. There are errors that begin to creep in over time. So just to give you one example of that, there were some researchers, they talked to a group of students on September 12th, 2001. Write down everything you can remember about yesterday, right? And then they came back at various time points and queried them and said, hey, tell me about September 11th. And so they had 2 different types of errors of treatment, one of commission and one of omission. Omission means you forget things. Things that you previously remembered, you've just forgotten some of the details. Commission means you're actually adding in or changing it. So for instance, one of the students said, I woke up and the radio was playing, that was my alarm, and I heard them talking about it. But, you know, a year later when he recounts it, I remember my friend calling me and telling me to turn on the radio.
Right.
So he's changed it just a little bit, but he's changed
Right.
that memory. And
Right.
so that happens. So each time we retrieve or recollect one of our memories, and again, we're primarily talking about our autobiographical memories at this point, but every time you do that, there is the opportunity now to reconsolidate that memory, to update that memory. And at that point, that's when these errors can creep in, right? It's like grandpa saying, you know, I caught a fish. Initially, it's this big. And then the next time it's this big. And over time, you know, the fish is, you know, this big before the story ends. Because each time he talks about it, each time he retrieves that memory, it's being slightly edited. It's being slightly altered. So here's the interesting thing about that is as humans, we like to tell stories, right? When you meet somebody new, you tell them about yourself and they tell you about themselves. And it's just telling stories. So for a lot of our memories, particularly our favorite memories that we like to sort of relate over and over, a lot of those memories have become semanticized, meaning they are a story at a certain point. You don't even have to access the actual original memory. You're just accessing the story that you tell to people whenever you meet somebody new. But the point is that there's some memories that we kind of retrieve and we like to talk about. So those memories, in fact, because you retrieve them so often and there's so much opportunity for error to creep in, those are the memories least likely to actually reflect the actual experience, right? Those are the ones that you probably have the biggest discrepancy between what actually happened at that moment in time and 2 or 5 or 10 or 15 years later, the story that you tell now to summarize that memory. Which memories are most accurate? Well, it's those memories that are buried in your head that you rarely reflect on or think about. Because those memories have undergone very little modification from the time they were originally encoded. Now, that's difficult because once you start retrieving them and thinking about them, then you open up these opportunities for the errors to creep in. But that's the important part here is that, again, our memory is not infallible, right? Our memory, again, is simply a representation, a best take approximation of what we experienced. And over time, that memory will continue to be altered as we continue to access it and think about it and ultimately modify it, usually subconsciously, but it doesn't detract from the fact that it's still being modified or altered.
Right. So emotional arousal can be helpful for encoding and retrieval, but can it also be detrimental? Like if you suffer from a traumatic event, can you suppress or fabricate memory?
Yeah, absolutely. Great question. So that is essentially the definition of PTSD, post-traumatic stress disorder. So in that case, you've had a traumatic experience, right? It could be an assault, violent, sexual, verbal, or otherwise. It could be a car accident. It could be because you're a victim of war, right? But the idea is that the experience is so traumatic that you really have difficulty even escaping it after the fact. So one of the defining features of PTSD is that memory is always intrusive, right? You try to push it down, you try to push it back, but it keeps popping up into the front of your head. You're always kind of thinking about it. You're always ruminating on that memory. Even when you go to bed, you can't get rid of it because it pops up in your dreams and other things. So as a result, that can change your behavior. You have depression and anxiety and other things that will come into play. But yes, that is an example where a memory really comes to sort of subsume the individual. And there's two things that are really happening there. So for many of our memories, particularly in a clinical setting, if there's something bad that happens, many times we can extinguish that memory, meaning we can sort of reduce the severity of it, right? So imagine that you are assaulted in a particular area of your city, right? Well, you know, the counselor may say, you know, think about this block or this street where you were assaulted, but you're perfectly safe. You're here with me. There's nothing to worry about. And so by activating that memory without the trauma associated with it, again, the idea is that you can extinguish or weaken that memory over time. PTSD by definition means that's not happening. You don't have that extinction. That memory remains as emotionally arousing as it always was. And in fact, it begins to generalize, meaning instead of just that one street, that one location, right?
Right.
Which now when you think about makes you anxious and you begin to avoid. You don't want to go near that street anymore. And you begin to generalize. Well, I don't want to go near that street, but in fact, I'm going to start avoiding that whole block, right? And there's a very popular restaurant or a store there. Oh, every time I think of that store, it stresses me out because I think about my assault. I'm going to avoid that store from now on. I'm not going to go there anymore. I'm not going to go to that part of the city because, again, it leads to this stress and anxiety, and I can't take it. Now, if you take that all the way to the extreme, that can lead to something called agoraphobia. This is actually an individual that shuts themselves inside. They don't go outside because going outside into the real world, again, it's too stressful. It's too anxiety inducing. So they kind of shut themselves inside in order to avoid all that. So yes, to come back to your original question, can that emotional arousal have deleterious or negative effects on our ability to kind of operate and kind of move through life? Absolutely, it can. Absolutely.
So thank you, sir, for your insights. It was lovely talking to you. And I'll stop the recording here.